so what on earth is that? I set it all up the same way I always set it up. I clicked go live, I streamed it, everything was the same as normal, and it just was like, no, not having it, no, not today. So I did everything I could. I rebooted my computer, rebooted my internet, changed the settings, copied settings, changed everything. Nothing worked. So I thought, last thing before I give up today, I will just try and set up a whole new video. Set up a whole new video. Yeah, that's fine. What is going on? Why is it doing that? I'm so mad right now. Oh, you don't even know. So yeah, there's that. So I guess let's start doing some straight line graphs. Hope you've all been keeping yourselves well. I will go straight into the thing. We've not got a PowerPoint slide today because with all the drama that was taking place, I didn't manage to finish all that off. So what I have got instead is my trusty whiteboard, which you should now be able to see. I can see. Hello to Sophie or Josh. Hello to Nina. Hello to Alex. Hello Soph. Hello to Funpug. I forget what your name was. I do apologise. Hello Lars. Hello Savannah. Hello Alicia. Hello the Sharpies. Don't know what was going on with YouTube, but thank you for moving over to this video. Yeah, just very, very odd. It means we possibly lost some people, but I'm hoping you can hear me now. So what we're going to do is, we've talked before about the gradient and y-intercept. This graph is about plotting. So if we've got the graph y equals 2x plus 1, before I can talk too much about plotting, we need to understand what an equation is. Because I know Savannah will only moan and say, I don't understand what you're talking about, and that's absolutely fine. This is an input-output situation. We're going to put in some inputs and get out some outputs. This is always, in these graphs, this one is always the output, and the x is our input. So what it is, it's a system, it's a machine, basically, because that is what a coordinate is. A coordinate is an input number, so let's say 5, 7. We know from year 7, year 5, year 4 that coordinates are, we go along and then up. So let's change it slightly so it's easier to do. Let's say we're doing 2, 7. We go along to 2, up to 7 and put a cross. But what we're really doing is we're saying when the input is 7, when the input is 2, the output is 7. It's a system. It's a set of a way of describing a system where when we put the number 2 in, we get out the number 7. And what a line graph does, an equation does, is it says, well, when you give an input, I'll always give you an output. Always. The reason it makes lines rather than points is because it doesn't choose what the numbers go in as. So in order to help us, we make a table of values. And it's always x, y, and I often do 0, 1, 2. You are allowed to do x, y, -2, -1, 0, 1, 2. You could, and sometimes in the questions you get given, that will be what you're shown. But I do 0, 1, 2 because once you've got 3 points, if they're in a straight line, the whole line is in a straight line. So what we need to do is take our input. Now the x is always the input. And so if I can delete some of this so you can make so it's not getting too clustered, what we're going to do is we're going to input the number 0 into this equation. And the way I do that is I copy everything out except the x. Y is going to be equal to 2 lots of, I put a bracket just to show that I've inserted something, 2 lots of 0 plus 1. 2 lots of 0 is 0 plus 1 is 1. So we write that as 0 input, 1 output, or 0 input, 1 output. Which means we can then, let me rub out the 2, 7, 1 now, because it's getting in the way. We can then, because it says 0 is the input, 1 is the output, we can plot that on this graph. 0, 1. There's our first point. The next thing we're going to say is, well, y also equals 2 lots of something plus 1. But when we put 1 in, it's 2 lots of 1 plus 1. 2 lots of 1 being 2, add 1 is 3. So we've got y equals 3. So y is 3 when the input is 1. 1, 3. We can write that down as 1, 3. So we go along to 1, up to 3, and put a cross. But we need 3 crosses to make a correct straight line and to make sure we haven't made any mistakes. Y equals 2 times something. Remember, this all comes from this equation. This is where I'm getting the 2 times something plus 1. Y output equals 2 times input plus 1. So therefore 2 lots of 2 this time. I'm putting the 2 in. Plus 1. 2 2s are 4 plus 1 is 5. So when we put in 2, we get the answer 5. Now this is why I hate the word answer. And I've just used it myself. But I'm going to go through, drill into why I hate the word answer. It's not an answer because y is a different output depending on the input. Another way of looking at this is to consider it to be a machine. When I put in 0, 1 and 2, I got out 1, 3 and 5. And that would go there in the table. Then I go along 2, up 5. But actually I didn't need to even put whole numbers in. Let me show you. If I now add a straight line, this straight line needs to go all the way through all 3 lines. And the final thing I have to do is I have to write the name of my equation, y equals 2x plus 1, along the line. Notice it does not stop here. It does not stop there. It carries on all the way through the graph, and we have the equation going up it. We've already talked in a different lesson about the fact that how steep this line is down to the gradient. We're only talking about plotting today. We're not talking about the gradient and y-intercept. I will remind you that we have already said before in a different video, so watch that if you're confused, that this is a gradient of 2 and it should cut through at plus 1, and it does. But we're focusing on the plotting side, which is the taking the 0, 1, 2. Now notice, if I'd have done the full graph, and sometimes you'll do a question, and it'll give you it'll give you all of it and some missing bits. That's fine. What that means is we've still got to find the missing ones here. I might say, what about minus 2? Okay, we just do the same thing we were doing before. I'll do these in blue so you can see that the negative ones are still the same format. 2 lots of plus 1. And we're putting in now minus 2 as our input. And we're getting out the answer. 2 times minus 2 is minus 4. If you add 1 to minus 4, you get minus 3. Remember to go up 1. So when the input is minus 2, the output is minus 3. Minus 2, minus 3, it's down here somewhere, but you can see it's going to, if you were carrying on that line, that's where it would go. Okay, and so we'd have minus 3, and you may have spotted, you don't even need to do it like this, because you can go at 2, 2, this one must be minus 1. And you can see there it is, it's minus 1 as well. You can do every point if you want, but you only need 3 points to do a straight line. Let's do a different one, just to show you that what I'm talking about was not a fluke. So, if I delete everything, I don't really want to delete the... I wonder how much I can do just by holding down the backwards button. Not much. So, let's just circle everything. You have to make the noise when you circle things. If you don't make the diddle noise, it just doesn't work. It's weird that way. And here we go. Sing a little song. And we're back to starting. So we've got an input and output, so we need a new question. Y equals 3x minus 2. So here's my steps. I know I've got an output and an input. So I'm going to do x, y, 0, 1, 2. This is called a table of values. I always like to explain why. It's called a table because it's a table, and it's called a table of values because it's got values in it. I can't explain it better than that. So what we're going to do is we're going to put, when we've got 3 lots of 0, 3 lots of 1, 3 lots of 2. Notice the input's changing. So we can remember, you could do it like this. You can do it how you prefer. I'm just going to have to change what my outputs are. 3 times 0 is 0. Minus 2 is minus 2. 3 times 1 is 3. Minus 2 is 1. 3 times 2 is 6. Minus 2 is 4. And then we put them into the graph because we can always make coordinates using these inputs outputs. 0 minus 2. 1 1. 2 4. Happy birthday, Soph. 0 minus 2 is going to go here. 1 1. 2 4. Then we get our straight line and we go all the way through. Do-dooby-dooby-doo. You have to do the dooby-doo noise. That's not the best, but there you go. And what's the final thing we have to do? We have to write the name of the line on it. Y equals 3x minus 2. Don't write the name. They feel left out. They're like, oh, you never tell me my name anymore. You don't even know my name. You don't know who I am. I'm real. I'm lovely. And you don't know my name. So you have to make sure you acknowledge the name. And remember, it goes all the way through. It doesn't stop. It carries all the way through the graph and out the other side. Okay. Now, hopefully this is... Has anyone got any questions that don't revolve around Soph's birthday? I'm just having a quick look. Nina's talking about Animal Crossing. So, anyone else? Anyone got any questions about literally the maths we're trying to do now? It's lovely seeing you all having a great time, but I will try and just make sure we're still learning. Otherwise, I might as well not be here. I could just leave you in a forum chatting together. So, I can hear baby crying downstairs. So I'm going to have to... We won't be too long today. I'm trying to do the best teaching I can and then going back and doing my shift. So, what about if it changes the format to try and trick you? Sometimes this can happen. But with you, when you're armed with correct information, it no longer needs to throw you. If it says x plus y equals 6. Now, this has got two approaches I like. One, you can do something called rearrange. We can go, well, we want the y, the output, on its own. So I'm going to rewrite it as y equals 6 minus x. I'm going to take the x to the other side by taking it away. That's allowed. Or you just go, well, the input and output are here. So do my normal x, y, 0, 1, 2. And so I've got 0 plus y equals 6, 1 plus y equals 6, 2 plus y equals 6. Then it's just a case of working out, well, what's missing? 0 plus something is 6, 6. 1 plus something is 6, 5. 2 plus something is 6, 4. Could have done the same thing here. Remember, we could have done y equals 6 minus 0 equals 6 minus 1, 6 minus 2. So they both give us the same set of answers, 6, 5, 4. We can then make some coordinates. Input, output. Notice I'm trying to always refer to coordinates as input, output, because if you do that, it makes the coordinates make more sense to you, but it's also longer lasting in terms of remembering what's going on. We've now got 0, 6, 1, 5, 2, 4. We've got one that goes the other way, but that's absolutely fine. We just grab the thing, straight line through these points. There we go. And the final thing you must remember is it's nothing without its name. X plus y equals 6. Now, the reason you can carry on is because straight lines don't have to be whole numbers. It's absolutely fine to say, well, what about 0.5? If x equals 0.5 here, what does y equal? Well, all you do is, once you've got the line, you go up at 0.5, read across, and go, oh, it's 5.5. That's all you need to do. You just look at it and go, well, I can read off from the graph. I can even do, like, if x is 1.2, well, I'm going to read up at 1. That's 1.1 probably. Let's be as precise as we can. 1.2. Let's do this in orange. 1.2 is probably about here. Up to there. I reckon it's about y equals about 4.8. Let's verify. 4.8 add 1.2 is 6. Yay! So you can see it does work. You can still get inputs and outputs that aren't whole numbers. So you use whole numbers to make plotting the graph easy, but we don't need you to do every single number, because all numbers in the world, including the decimals, and even smaller decimals than this, like 4.76232, could be found using the graph. But we just plot the whole numbers, and we only need 3 to get the straight line graph that it goes with. Now, with that process, you can now draw any straight line graph. But Mr. Harris, how do I know whether it's going to be a straight line? Well, there is a tell. If I look at these lines, y equals 3x plus 4, 2y plus 3x equals 7, y equals x squared plus 9, y equals x cubed plus 2x squared plus 3x plus 5. The two that we know will be straight lines are this one and this one. And this is because when it's got a normal amount of y, the biggest amount of x is just normal x. That's what tells us it's a straight line. Anyone who joins me on Friday will find out about quadratic lines. I think it's Friday, I've got it down. If it's got an x squared in it, it's not a straight line. It's this weird bowl shape, which we'll do more about on Friday. But it's going to make a bowl shape or a mound shape whenever it's got an x squared in it. And in fact, if it's got an x cubed, it ignores the x squared. It ignores the x. It only looks at the highest amount of x, the highest power. So this one would actually be sort of this shape. It makes this weird shape. Or if it was negative, it would go. So these are called cubic because it's got cubed. These are called quadratic. But what you've been learning today is straight line graphs, and that's why they're called linear or line R. Linear graphs are always straight lines. So if it's got just a normal amount of x, it's always going to be a straight line like that. If it's got x squared, it'll be a quadratic, so it'll be a curve. It's like a smiley face. And if it's got x cubed, it's going to be a cubic. We're only focusing on the straight line ones here. And a summary of what you have to do. Number 1, draw a table of values. 0, 1, 2. Number 2, we then put the values in by remembering it's an input-output table. Then when we've got that, plot the coordinates. Then when you've got that, straight line. And finally, name. Now, with that in mind, I've put in the description below a link to some questions. I thought we could do the first one together, so here we go. Hopefully you can see what I can see, which is a first question. Now, looking at this, I should probably have found a way of copying it. So, let's copy paste it. We're going to take all of that, steal it, and I'll even talk to you about why it's worth 4 marks. So we'll go a new page, and we'll paste that, and we'll drag it, so I'm not in front of it. So it gives us a table of values. As I mentioned, tables of values, here they go. This is what it means, table of values. So it's given us those, and it only wants 3 of the values that are missing. Look, it has done 2 of them for us. So to do those table of values, we just need to remember input, output. Y equals 2 lots of -1 plus 5. Y equals 2 lots of 1 plus 5. And y equals 2 lots of 2 plus 5. Now, just in case there's any confusion still, what I'm going to do is put those in a different colour so you can see where they've come from. These are the input numbers that are at the top here. There, there, and there. 2 times -1 is -2. Add 5 is 3, which is why I'm writing a 3 in there. 2 times 1 is 2, add 5 is 7, which is why I'm writing a 7 in here. And 2 times 2 is 4, plus 5 is 9, which is why I'm writing a 9 in here. I now can check for 2 marks. That means I have to have all of those things correct. 1, add 2 is... So these goes up in 2s, so we're quite happy it's going up in 2s. I can now plot them all. Because it's given me them all, why not plot them all? Minus 2, 1. I'm going to put a little dot. You can put a dot or a cross. Minus 1, 3. Put a little dot. 0, 5. Put a little dot. 1, 7. And the cool thing about this is it kind of tells you whether you're right. Because if any of these weren't in a straight line, you'd know you'd gone wrong. Because we knew we were expecting a straight line. So then when I draw this graph, this line, it might need to come down a little bit. I think I can drag it. Not easily. That will do. The final stage of our steps is we write the name. But sir, do we get marks for the line? I don't care about the marks. I care about doing it properly. Thank you very much. Marks are irrelevant to me because I don't really care about right and wrong. I care about understanding. If you understand it and you understand why we're doing it, you stop worrying about the marks. Okay. Any question? Oh yes, that's a good idea, Alicia. So I will post the timetable on the community chat. I hadn't thought to do that. Sorry. So there we go. That is exactly, and we get 2 marks. 1 for the correct plots and 1 for the line. If you don't draw the line, you only get 1 point, which is why it's worth 4. So make sure you do it all. That's been a lesson on linear graphs. I hope it's been useful. I hope you've learned something, Alex. I hope you learned something from Pugs and Nina. I hope you understand what's going on. Is that a nope you don't understand? I hope you, if you've got any questions, please let me know. I hope it's not too blurry. It says excellent condition now on the thing. I don't know what's going on with YouTube, why it's been playing me like a fool. But if you have learned something today, feel free to like and share. Feel free to tell people about it. Hopefully it's been useful. I know being stuck at home can't be great. But for 10 of you today, you've learned some stuff on drawing straight line graphs, and it means that you're carrying on improving your maths. You won't be falling behind, because this is what we would have been doing in class. So especially for, I think, Alex, this is actually what you're supposed to be doing for this week's maths. I think. So it might actually be very, very useful when you go off and do your work at First Plat. So, thank you so much for joining me. I've been Mr. Harris. You haven't. Take care, look after yourself, and I'll speak to you later in the week.